Today we're going to talk about quadratic equations, and we're going to start with this idea, linear equations. This is from chapter 1. And when we did linear equations, maybe you had something kind of like this, like 2x plus 5 equals 13. And we said solve this equation. And your focus when you solve linear equations was to get this variable by itself. You wanted to pick things off, make some moves so that way you got the equation to say x equals something, right? And so when you did this, you'd start out by saying, I don't know, you'd say minus 5 from both sides. And a lot of you would probably just do this right in your head. So you get 2x equals 8. Then your next move would be divide by 2, and these 2's cancel. You get x equals 4. And you were done, right? So the idea was isolate the variable, okay? So with quadratic equations, the idea is sort of the same. And so let's start out with probably the most basic quadratic equation you could have. X squared equals 4. So this is a pretty simple quadratic equation. Notice it's a quadratic because it's a squared. You know, we now have a squared term. And so how do you solve this? What do you do to both sides? Yeah, exactly. Yeah, square root both. So we get x equals, because the square and the square root cancel each other. What's the square root of 4? 2 and negative 2. So yeah, there's actually two answers to this. Sort of like when we did absolute values and we had two answers by branching. Square roots are the same thing. You get two answers. It's positive 2 and negative 2. Now, for most of your math career, you've only focused on the positive 2. This is called the principal root. And you maybe acknowledged that there were two answers for about like 5 minutes, but then someone said, we're going to ignore the negative answer. We're only going to work with the positive answers. And the reason they did that, we're not going to do that, by the way. We're going to consider both. The reason they do that is because if you were to graph f of x equals the square root of x, you'll get a graph that looks something like this. And this is the graph of the principal roots, all the positive values. However, it's only half the story. There's actually all of the negative answers. This is the square root of x. This is negative square root of x, not a function. Functions are specific things that for every single input you have, there's only one output. And the graph, the real graph of the square root of x, fails the vertical line test. 2x squared minus 5 equals 7. Solve this. So again, your focus is going to be on this variable right here. Let's get rid of some stuff and get that x by itself. So what's your first move? Add 5 to both sides. So plus 5. And that's going to give us 2x squared equals 12. Next move, divide by 2, zip, those 2's are gone, and you get x squared equals 6. All right, next move, square root, and we get x equals plus or minus the square root of 6. When you are typing this into the computer system, SQRT 6, comma, negative SQRT 6. What's your first move here? Square root both sides, right? So the square and the square root cancel each other, and you are left with just x minus 3 equals the square root plus or minus the square root of 7. Add 3 to both sides. Plus 3. So you get x equals 3 plus or minus the square root of 7. This format that we got this problem in, and let's put in some generic variables. What if we said something like x minus h squared plus k equals 0? Let's say that we wrote it like this, okay? You can solve this for any h and k in 3 moves. 3 moves, and you got it solved. So this is a really nice format. Yesterday, we found the vertex and the line of symmetry, and we also found the y-intercept. But there were two other points that are kind of important that we weren't able to solve for. And these are the x-intercepts, where the line goes through the x-axis. So we want to find these points. And you may remember the y-intercept is when x equals 0. So that means the x-intercept is when y equals 0. So if I have a quadratic, ax squared plus bx plus c, and I set it equal to 0, this will give me the x-intercepts. X squared plus 3x plus 2. And we want to find the x-intercepts. Okay, we could find the vertex, we could find the y-intercept, okay, we know all that stuff. We're looking for the x-intercepts. So we're going to take this thing and we're going to set it equal to 0. X squared plus 3x plus 2 equals 0. And now the question comes up, how do you get x by itself? The tools that we used before, up to this point, don't work. You can't subtract 2 from both sides and get x by itself. You can't divide by 3 and get x by itself. We have to come up with a new mathematical tool in order to get x by itself. And you probably, hopefully, have seen this mathematical tool in the previous course. In order to solve this, you're going to have to do something called factoring, or unfoiling. Okay, so if you know what FOIL is, first, outside, inside, last. So here we go. You may remember this. Zip, zip, parentheses, x and an x. And now you play this little game, right? The game is, what are factors of 2, numbers multiplied together that give you a positive 2, that when added together give you a 3. 1 and 2. So this becomes x plus 1 and x plus 2. And we've now successfully factored that quadratic. If you're in doubt, you can always FOIL it, run the system backwards to see if you get back to where you started. So the f, here's the f, the first term. So that's x squared, x times x. The o is 2x. The I is 1x. And the L is 1 times 2, which is 2. And if you've done these enough, you get used to the idea that usually the O and the I are common terms and you can add them together. So you get x squared plus 3x plus 2, which is exactly the same as what we started with. So we know we did it right. You know, you unfoil it, then you refoil it, and you get back where you are. So we're good to go. So this tells us that x plus 1 times x plus 2 equals 0. What makes this true? What values of x?
-1 and -2.
So x equals -1 and -2. So the one that we just did was f of x equals x squared plus 3x plus 2, right? That's the one that we just did. And we said, okay, it goes through the x-axis at -1 and -2. Great. No worries, piece of cake. All right, let's change one number. I'm going to change the 2 to a 5. So now we have x squared plus 3x plus 5. And we want to find the x-intercepts. So again, we'll just say x squared plus 3x plus 5 equals 0. And we'll just FOIL this middle part. X and x, okay. So what are factors of 5 that when added together give you a 3? 1 and 5? 1 and 5. Oh, well, that doesn't work. All right, well, then it must be 5 and 1. That'll do it. Oh, no, that doesn't work either. Any other factors of 5 that you can think of that add up to 3? How about 10 and 1/2? Oh, that doesn't work. Does this mean that the graph doesn't have any x-intercepts? I mean, if we graph it, is it like, oh, I can't find the x-intercept, so it must not have any? No, if you graph this, it has x-intercepts. Of course it does. It's just the technique that we had before, the previous techniques, this technique that we used, the unfoiling, fails us. Because when you did foiling of equations, those problems were rigged. They were nice numbers, meant for you to be able to solve. What happens when you run into numbers that aren't nice? Yeah, that's right, you say. You go to Wolfram Alpha, you plug it in, and say. So, wouldn't it be nice if we could take this equation that we can't solve with our normal techniques? What if we could take this quadratic, and what if we could transform it into this? If we could take ax squared plus bx plus c, and if we could manipulate it and change it and shift it and do some things and make it look like that, then we could solve it easily in 3 moves, right? We'd just kick that k over to the other side, we'd square root both sides, we'd add h, and we'd be done, and we'd be able to solve it. So how do we get this nasty looking equation? And if you don't mind, I'm going to change one thing on this to make it easy. I'm going to make this an 8, if that's okay. And you'll see why in a little bit. I'll make that an 8. So, and again, still, even if I change it to an 8, we still can't do it by foiling, right? What are factors of 5 that give you an 8? I can't do it, whole numbers. So, boy, okay, so this is what we're going to do. We're going to do this. We're going to say x squared plus 8x plus 5 equals 0. Remember, when we set it equal to 0, this will give us our x-intercepts. Then we're going to do this. X squared plus 8x plus some number plus 5 minus that same number equals 0. And we're going to call this number, I'll just call it a smiley face, right? Because I don't want to give it like a value, like an X or a Y or something. I'm just going to say smiley face, the blank. What goes in the blank? So we're going to say x squared plus 8x plus something. And then in order to keep the equation balanced, we have to subtract the same something after the 5, right? Get it? So we're going to add a smiley face here, and then we're going to subtract the same thing later on in the same side of the equation. So we're still net 0, right? Like we're not really tweaking anything. So this is a legal move. All right, so what goes in the blank? So smiley face is equal to b over 2 squared. Trust me. And we'll show you why in a little bit. Because I really don't like saying, just do this because it works. All right, we'll show you why b over 2 comes into play. So if you take b, which is 8, and you divide it by 2, and then you square that number, what do you get? 16. 8 divided by 2 is 4. 4 squared is 16. 16 is what we're going to add and then subtract to this equation. Plus 16 minus 16. So everything stays balanced. Plus 16 minus 16, we're balanced. Okay? We haven't done anything tricky. This component that we used, that we added 16 to, now is a perfect square. This actually factors into x plus 4 times x plus 4, which is x plus 4 squared. Well, this part is just kind of like the residual. You know, whatever happens, happens. So positive 5 minus 16, I think that's going to shake out to be, what, 5 minus 16, negative 11, equals 0. Whoop. So now we have x plus 4 squared minus 11 equals 0. Hey, now we can solve this. We can solve this in 3 moves, right? What are you going to do? Add 11 to both sides. Okay, so here we go. Plus 11, plus 11. Whoop, whoop. So we get x plus 4 squared equals 11. Okay. Square root both sides. So we'll get x plus 4 equals plus or minus the square root of 11. And then finally, minus 4, minus 4. So now you get x equals negative 4 plus or minus the square root of 11. So that means that if we were to graph this, our left-hand x-intercept would be negative 4 minus root 11, and our right-hand x-intercept would be negative 4 plus root 11. And you might be, I don't believe you. Okay. So what is the square root of 11 approximately? The square root of 9 is 3, and the square root of 16 is 4. So the square root of 11, because the square root of 11 is in between the square root of 9 and the square root of 16, the square root of 11 has to be in between 3 and 4. Is the square root of 11 closer to 9 or closer to 16? That's closer to 9. So instead of 3.5, you're going to lean a little bit more towards 3. So you're going to say, yeah, it's probably about 3.3. And that's good enough for our purposes. So you might say that your left hand would be negative 4.5 or negative 4 minus 3.3, which is about negative 7.3. About negative 7.3. And the other one would be negative 4 plus 3.3, which is approximately, what, negative 0.7. So here's one x-intercept, right here. Here's the other x-intercept, right? Where's our line of symmetry? Opposite of b over 2a, remember that from yesterday? So we could do opposite of b over 2a. And so from our equation, let's see, b is 8 and a is 1. So that would be opposite of 8 over 2 times 1, which is negative 8 over 2, which is, negative 4. So that means our line of symmetry is negative 4. X equals negative 4. X equals negative 4. Negative 4, negative 4. Do you see a negative 4 anywhere else in this problem? So think about this. Remember that line of symmetry, right? So x equals negative 4, and the distance from here to here, the distance from your line of symmetry to the first root, this distance is plus root 11. And this distance from here to here is minus root 11. Negative 4 minus root 11, negative 4 plus root 11. See the symmetry? There's a reason why there's a plus minus there. This is your line of symmetry. And these numbers, the plus root 11 and the minus root 11, those numbers are the distance off of the axis of symmetry that your x-intercepts are located. This whole idea that we did here, this is called completing the square. Completing the square. It's a process by which you obtain a perfect square. So completing the square. So we really have kind of like two formats of a quadratic equation. We have the standard form, which is this guy. And then we also have this completing the square format, which is really handy because you can solve it quite easily. Wow. Hey, there's a number in this one too. Look at that. Hey, what's that number? That looks like it could be something important. I wonder if this number is anything important. What? So what you're telling me is you think that the vertex is negative 4, negative 11? The vertex is, and actually, when we call this format up here, the standard format, we know what that is. We don't call this format completing the square format, because that's a lot of words to say. This is called vertex format. This was kind of a learning exercise. Let's go through one from the top. F of x equals x squared plus random number. Anyone? 8. We just did one with 8. 7. All right. 7x and then another random number. Minus 2. Okay, there we go. Run complete the square. So we'll say x squared plus 7x plus blank. And again, I'll just put that smiley face in there. Minus 2 minus smiley face equals 0. So we take our function, we set it equal to 0, number 1, that tells us we're getting the intercepts, and we put in our blanks with a smiley face. So what is smiley face equal to? B divided by 2 squared. 7 divided by 2 squared, which is 49 over 4. This is what has to go into the smiley face slots. So we're going to put 49 over 4 here, and 49 over 4 and the second one. So one's a plus and one's a minus, right? Because if you add something to one side of the equation, you have to subtract it from that same side to keep everything balanced. And now, believe it or not, this is actually a perfect square. So you could spend a lot of time unfoiling this thing, or you could take a little detour right here. When you took b and divided it by 2 before you squared it, that is your term. 7 over 2, 7 over 2. X plus 7 over 2 squared. And if you don't believe me, go ahead and FOIL it out. It works. So you're going to take this negative 2 and you're going to write it as negative 8 over 4. Is that better? And then negative 49 over 4 for a grand total of negative 57 over 4. Okay, so now we'll go up here. And remember, this whole thing's equal to 0. So we have x plus 7 halves squared minus 57 over 4 equals 0. And now this guy is in vertex format. By the way, what is the vertex? That is the vertex. An added bonus. Okay? We haven't gotten to the x-intercepts yet. So we're just halfway done. Now we're going to solve this. And we're going to solve it in 3 moves. You may be looking at this and say, well, I've got a common denominator. Let me put them together and make it simple. No, leave it in this format. And the reason you want to leave it in this format is because right here is your line of symmetry, negative 3.5, which should match the x-coordinate of your vertex. If they don't match, you've done something wrong. And then we could talk about, well, could you graph this? So if we sketched a quick graph, negative 3.5, 1, 2, 3, 4. So here's negative 3.5. There's your line of symmetry. And your vertex is located at negative 57 fourths. Oh, that's a big, really negative number. Negative 57 fourths down here. So here's your vertex. And your x-intercepts are going to be plus square root of 57 over 2 this way, whatever that number is, and minus square root of 57 over 2 that way. Zip, zip. You can now find the y-intercept, the axis of symmetry, the vertex, and the x-intercepts.